I am a technical marketing engineer with NetApp, which kind of at the core really means that I don't get any respect from marketing or engineering, right? Both are in my title. So the other joke I like to make is that it's only 1/3 technical, right? The rest of it is just kind of make it up as you go. So I have a long history inside of IT. I started in roughly 2000, working with Department of Defense, working with the government, doing a lot of different projects inside of there, including doing things like early VDI deployments back in the late 2000s. And really my goal, my journey at that point started with automation. I started automating back before it was in vogue, if you will. Mr. Glenn Sizemore and I wrote the first version of the PowerShell toolkit for NetApp. Right? We wanted the capability of being able to take, well, ONTAP, we wanted to take the capabilities that were happening inside of there and surface them up as far as possible. And it just so happened that NetApp took notice and turned it into an official thing. They, of course, discarded all of our code in the process, but that's okay. So now, I spend a lot of my time as a technical marketing engineer living in what we call the open ecosystems. Open ecosystems is a relatively new twist on an old team inside of NetApp. You see, we've had an OpenStack team for a long time. Right? OpenStack team since roughly 2011, 2012 timeframe, back when we first started contributing to the Cinder project. But over the last 18 months or so, it turns out that, well, open source isn't just a flash in the pan, right? It turns out that all of these projects, all of these things that application administrators, application developers, system administrators, storage administrators are using, open source tools are becoming the more successful ones. So what we did was we made the choice to expand the responsibilities of our OpenStack team into an open ecosystem team. What we lovingly and fondly refer to as the pub is our online presence. So the open ecosystems team is responsible for, among other things, Puppet, Chef, Ansible, OpenStack, containers, Kubernetes, Jenkins, anything that you can find on github.com/NetApp falls underneath my team. Now, why did we do it this way? Why did we take our OpenStack team and expand it? It turns out that contributing, participating, operating in the open with open source projects is a little bit of a skill set itself, especially when you work at a company like NetApp. Right? We're known for being, well, a proprietary storage company. But we want to operate in the open. We want to work with the community. And I'll talk more about that in just a few minutes. So a quick recap for anybody who isn't familiar with the history of NetApp. This is our 25th year. 25 years ago is when Mr. Dave Hitz and company sat at a bar and wrote on a napkin the layout for Waffle. In the May and June timeframe, you'll probably see some fanfare that goes with that. But over the years, over these 25 years, as ONTAP has improved, has expanded its functionality, so has NetApp's portfolio. We've expanded to include things like, well, SAN storage, even inside of ONTAP. But we also grew it through E-Series. We've grown it through SolidFire. We have object storage with StorageGrid WebScale, which we had an announcement this week. StorageGrid WebScale 10.4 was released with containerized deployment. We have cloud-based backup. We have cloud-based storage. So NetApp's portfolio has continued to grow and improve and expand over these last 25 years. Whether you're leveraging storage on-premises, off-premises, attached to the cloud, adjacent to the cloud, in your data center, it doesn't matter. The core principle is that your data is where it needs to be. We can migrate that data around across premises so that the applications can leverage it where they need it. This is the core tenet behind our data fabric strategy, enabling and empowering applications. So I mentioned a moment ago the pub. Open ecosystems, my team, where we fit in, what our core mission is. And it's pretty simple when you think about it. We want to enable developers. One of the things I like to say is, well, how often does even a virtualization administrator get access to things like a storage level snapshot? Not terribly frequently, right? Maybe if they're using something like a virtual storage console from NetApp, right, our VM or vCenter integration, right, they might have access to it. Even more critically, how often does an application administrator or developer have access to things like storage snapshots, storage clones, things that can critically and beneficially impact the application lifecycle? They don't. One of the core goals of all of these tools, all of these open source things that my team manages, is to enable those developers to consume storage and storage features leveraging the native tools that they're using today. We don't want you to learn how to use storage. We don't want you to have to care about things like RAID groups or storage virtual machines or lifts or any of those other things. We don't want you to care about where your storage is at or even what protocol it's leveraging. All you want to do is be able to say Docker volume create. And guess what? It's on an enterprise storage system. It has massive performance. It has reliability and availability. Consuming storage at the application layer without having to wait on the storage team. Second to that, our second tenet is to operate in the open. As I mentioned before, we want to operate as much as we possibly can, leveraging open source tools that the community is using, like GitHub. If you go to GitHub, you can see a list of issues. You can see all of the problems that our users have been having and the responses that we have to them. You can get an idea of our roadmap. Right? We publish what our release cycle is. Our goal is to make this as transparent as possible. And of course, we love things like pull requests. We love when our community, when our users contribute back into these open source projects. And we encourage anybody and everybody who is wanting to improve our products. We would very much like that as well. This brings me to the third one, be good citizens. It's a little bit like don't be evil, right? But that's a different kind of company. Be good citizens means that ultimately we want to contribute back upstream. Right? My next slide talks about our contributions into the OpenStack ecosystem. But it's not just OpenStack. We drive resources further upstream into things like Ansible and Puppet. We have many, many, many contributions across the entire ecosystem. But not all of those are necessarily as code, and this brings me to the fourth bullet. Not always is it contributing code upstream. With many of these projects that I'm talking about, things like Kubernetes and Docker, they still have a relatively primitive understanding around persistent storage. And it turns out that in 25 years, we've learned a thing or two about storage. Right? We kind of figured out some of these difficult things. And importantly, our experience from things like Cinder and Manila means that we can help to mature those paradigms inside of, for example, Kubernetes. So we want to work with those special interest groups, whether it be Kubernetes or Docker or Jenkins or whoever it may be, in order to, well, mature their understanding. Introduce things like snapshots and clone, and drive that upstream, drive that into the core product. Because it benefits not just NetApp and our capabilities, it benefits the community. And when developers, when applications can take advantage of those things, everybody is more successful. Because ultimately the goal is to drive better business outcomes. So where's the proof behind all this? Where is this actually tangibly seen? As I said a moment ago, the next slide is about our open source contributions, specifically in the OpenStack project alone, arguably our oldest and most prolific of the open source projects we contribute to. Now you'll notice that the combined NetApp and SolidFire organizations are by far the largest corporate contributor to the Cinder project.
How much of that was SolidFire due to acquisition against what NetApp has done internally?
Please correct me if I'm wrong, but I believe that NetApp's number was roughly 9%, old NetApp, and SolidFire was roughly 5%.
NetApp was about 12, SolidFire is about 9.
Okay.
I forget what the number is right now, but
Okay.
we're about a third more.
Okay.
Thank you, Brendan. Similarly with the Manila project, if you're not familiar with Manila, Manila is file shares as a service. Of course, this is in our best interest. We are NetApp, right? We are a NAS company. So we introduced the project. We are the project lead behind it in order to provide the same sort of storage consumption model with Cinder and block storage, leveraging files and file-based NAS protocols. And you can see that either NetApp directly or NetApp through our friends that we have endorsed and that we have empowered is a major contributor into that project. And we've seen a substantial amount of success as a result of that. Manila is now production ready. I say that knowing that it was actually declared production ready 2 releases ago, and adoption is growing. So NetApp is not unfamiliar with open source. This isn't new to us. This isn't strange. But what is new is this renewed and more invigorated focus on open source, on participating in the community, and most importantly, driving up the stack, enabling applications, enabling developers, enabling administrators to consume storage resources. So serendipitously, all of this happens to come together really nicely in a very concise term. DevOps. DevOps was originally coined in roughly the 2010, 2011 timeframe, depending on who you talk to and what blogs you read and how the tea leaves look that particular day. And DevOps is, well, it's a really friendly, really concise way of saying something that is really not that friendly or easy to understand. You see, we have roughly 30 people in this room, give or take a few, even though there's only 12 delegates, but I can guarantee that every one of us has a different definition of DevOps. For anybody who's been around for more than about 15 minutes, you remember cloud. 5 years ago, everything was cloud. It had to be cloud. Cloud washing became a term. You could almost argue that DevOps is reaching the same point these days. Everything needs to be DevOps, but we don't necessarily understand what that is. So I like to start these things with doing a little bit of a level set. What is DevOps? What does DevOps mean? And importantly, for you, what does DevOps mean for NetApp? So that when you hear what we're putting out, when you see what we're doing, you understand the context that we're doing it in and where we're coming from. And of course, we operate in the open. We encourage community contribution. So if our perspective is wrong, help us, correct us. That's why we're here. That's why we are an open source team. So the first thing that I like to ask is, why does DevOps matter? And I like to ask a simple question, almost always towards infrastructure operators, not towards developers. How long does it take to deploy a line of code? I got a bug request. I got a feature request. I made a typo. How long does it take for that to reach my customers? How long does it take for those web page users, for my application users, for my mobile app users to accept and realize that I made a mistake and oh yeah, we fixed it? DevOps facilitates this. DevOps is the concept of communication between development organization and operations organization. Really nothing more than that. Opening lines of communication, going out and having a cup of coffee or maybe a beer, depending on the time of day, with your counterparts. But it's not just how quickly can I deploy. We want to leverage those tools. We want to leverage the underlying infrastructure and the features that it incorporates in order to safely deploy that line of code to production. I was fortunate enough to be involved in the general session at Insight last year on day 3. We had what is considered a very unique demo on stage, especially for day 3. Day 3 is usually the more technical sessions at Insight. In that our demo was really more of a skit. It was really more of a play, where we demonstrated the power of these concepts of automation, of DevOps, of open collaboration and communication between development and operations organizations. Where we showed what happens when our intern, Mr. Josh Atwell, creates a bug. Creates not just any bug, a data corruption bug in an application. And how quickly can we leverage these tool sets, the modern tools that are being used by applications teams, things like Docker, things like Jenkins, things like Puppet, Chef, Ansible, to recover from that and redeploy and ensure that, well, we get back operational, back to making money as quickly as possible. So safety is really a key paramount here. Not just how quickly can I shove something out the door, how quickly can I shove it out the door and make sure that it is going to operate correctly. So I asked Google, very simply, right? How does any good system administrator start his day? He asked Google, right? What is DevOps? And I had a great time with the responses. Just like I said, right? Everybody in this room has a different perspective, a different definition of DevOps, and so too does the internet, so too does Google. You can see that each one of these are, at the time, they were quite literally the 3 top responses for what is DevOps. They're drastically different. But they also have some core similarities. Things like philosophy, practice, right? Things like processes, culture. You notice that only once does it generically note tools. DevOps is not a team. It's not a person. It is a job title, though I think most people that you ask that have DevOps in their title do it a little bit tongue-in-cheek. And we do encounter DevOps teams. I'll touch on that in just a moment. But ultimately, at its core, DevOps is facilitating communication, better business outcomes. That's the entire goal. So what is a DevOps team? You're probably thinking to yourself, well, Sully, you did a fantastic job of telling us that DevOps is nothing more than kumbaya singing around a campfire, right? When the rubber meets the road, when we actually want to leverage that infrastructure to its maximum, when we want to take all of those features, all of those capabilities that are surfaced at the storage, at the network, at the compute layers, and make them available to those application developers, all of that rubber meets the road at automation tools. They're all automation tools in some way or another. They may have different perspectives, they may have different scopes, they may have different feature sets, excuse me. But ultimately, automation is how we enable that. Yes, we still need to collaborate, we still need to communicate so that the developers, the application teams understand what the infrastructure is capable of and how to leverage that. But when they actually want to use it, it's being done through automation. Sometimes that's the development team writing code. Sometimes, particularly in large enterprises, that's a DevOps team that acts as that in between. They're the ones writing the automation layer on top of the infrastructure. They're the ones communicating with the applications teams and asking them, what functionality do you need? Prioritizing that, making it available to them. So DevOps is both a process, it is communication, it is automation. And while I can't guarantee, I can't promise that anything will ever make developers write better code. I was sadly a developer for a very short period of time and discovered I'm not very good at it. What we can do is increase the quality of the end result. We can do things like continuous integration and testing, leveraging that tool set, leveraging the data, the actual application data, in order to test against the production environment and ensure that we don't introduce a data corruption bug. So while I can't write better code, I can at least make sure that my code isn't going to catastrophically break something. So when we look across the DevOps ecosystem, there is quite literally hundreds, if not thousands of tools. This is a fantastic chart that comes from the Zebia Labs guys. Right? This is the periodic table of DevOps tools. Right?
Wow.
This is just a small sample. I contemplated putting in a slide here that has several hundred logos, except that usually most people get distracted by that and they're focusing on finding their favorite companies instead of what I'm saying. But the key here is that, well, all of these tools, and you can see they're broken up into categories by color, they all have the same general functionality within those categories. Unfortunately, much to the chagrin of both myself as well as my management, we are a company of limited resources, which means that we have to focus on, well, a few. It means that we have to focus on those that are most popular. We want to enable as many people as possible, as quickly as possible. So through the remainder of the presentation, essentially what we're going to look at is the most popular set of tools that we have found and how we are enabling those tools, how we are enabling the management, the consumption, the utilization of storage, leveraging those DevOps tools. So I mentioned before that I'm part of the Open Ecosystems team, thePub. I spend roughly 80% of my time on one specific area of open source integration, containers. Everybody loves containers. We all hear about containers. Containers are the future. I can't tell you how many times I've heard Kubernetes this week at OpenStack Summit. I can't tell you how many times I heard Kubernetes and OpenShift last week at Red Hat Summit. Containers are a thing.
How many times are you hearing that at customer meetings?
Extremely frequently.
With what sort of roadmap and lead? I'm not arguing with you. I'm just, you go to Red Hat Summit, you go to OpenStack Summit, all right, huge vats of Kool-Aid all over the place. But from a customer side, how often are you hearing that in discussions with NetApp, asking about containers, asking about Kubernetes, asking about those sorts of integration work? Absolutely.
So that's a fantastic question. And I'll first caveat it by saying, remember that we have an uphill battle here, right? And that NetApp is a storage company. We sell infrastructure historically to storage administrators. Storage administrators, I like to make a little joke that they're the new DBAs, right? DBAs for a long time, it was don't touch my stuff, stay away from me, right? The database is up and running, right? I don't need to change. Storage administrators are largely the same way, right? Don't bother me, the storage is running, we're not losing data, the business should be happy. But it turns out that, well, applications need access to, they want to drive more value out of, well, that infrastructure pieces. So NetApp as a company is learning how to reach out, how to communicate, how to interact with those administrators further up the stack. So what does that actually mean? Well, things like I do a lot of EBCs out of our RTP office. Over the last 6 months, I went from doing previously 1 DevOps or containers-related EBC to I've done no less than 6, a little more than 1 per month. I have 4 coming up in the next 6 weeks. So my anecdotal evidence is that it's accelerating. I've been, whether you consider it a privilege or a curse, I get mailed out to things like DevOps days, where we get 2 different types of people approach our booth or our table, right? I know NetApp, why are you here? Or I don't know NetApp, what do you do and why are you here? And it's almost always the same message of empowering, enabling the application to consume storage. And they like that message. Right? Remember, the storage platforms stand for themselves. I don't need to sell the storage platform to the application guy. I need to sell the consumption, the utilization of those features. And let the storage team, because there's still a storage team, there's still infrastructure administrators, pick the one that works best for their model, for their skill set, for the things that they want to do with it outside of just what that application team is doing. So containers are accelerating. Containers are an interesting technology. Containers are not a new technology. Even though most of us, they really only came into our consciousness about 3 years ago when Docker came to light. The reality is containers have existed in one form or another for probably 25 plus years. Solaris zones, BSD jails. The current iteration of Linux containers is based off of namespaces and cgroups, technologies that were introduced by Google in roughly the 2006-2007 timeframe. They're not new technology. Before Docker, we had LXC, among other things, all for enabling the consumption of containers. So they're not new technology, but suddenly everybody has become curious about containers. Suddenly, everybody wants to use containers. And I think it's important to remember one important, or among many other things, it's important to remember that a container is not a virtual machine. It's not a virtualization technology. Containers are process isolation. That process could be quite literally anything: Bash, Perl, Python, Java, a compiled binary. It could be any number of things that's running as an isolated process. It has been fenced off from the rest of the kernel, leveraging namespaces. This is different than a virtual machine. Virtual machines are exactly what the name implies. It's a virtual server. I have a virtual motherboard that has virtual BIOS, that has a virtual hard drive attached to it and virtual network adapters attached to it. And importantly, I have on that virtual hard drive is an operating system. An operating system that has to be loved and cared for and fed, patched. An operating system that has overhead. With a container, I'm simply instantiating a process. It takes a few milliseconds. I'm not doing anything fancy. But oftentimes we confuse containers with virtualization because we can do things like Docker run Ubuntu. And inside of there, in that bash process, it looks like, tastes like, smells like, feels like Ubuntu. But what we're doing here is simply attaching a new root file system to our process, one that happens to follow the Ubuntu file system layout, one that happens to have all of the libraries, binaries, right, helper scripts, everything else associated with Ubuntu. But there's no init, there's no systemd, there's no cron, there's none of these other things that make it a true operating system. It's simply an environment. It's a set of tools that follows around my core application binary. So you notice only once during this conversation about containers and what they are have I brought up Docker, right? And that was just to illustrate instantiating a container. You see, Docker is what I like to call the Kleenex of containers. Right? Kleenex is a name brand for a facial tissue, right? Docker is a name brand for containers. Docker, through their open source projects, they facilitate many other projects that are taking advantage of containers, but they also have their own value add. Things like the Docker image system, which allows me to simply and easily create, manage, maintain those Docker images. So that when I say Docker run Ubuntu, I can quickly create that image. It knows how to pull that down from Docker Hub and instantiate it. But the core power the real reason why developers, why application administrators love containers is because it provides isolation, it provides encapsulation to my application. You see, what virtualization did for servers, decoupled the operating system from the hardware, containers are now doing for applications. They're decoupling the application from the operating system. They're making it so that I can write an application, I can execute it on my laptop, I can hand it off to my peer and say, can you please test this? Can you please debug this? Can you please add to this? And it is going to execute, it is going to behave, it is going to act exactly the same on his laptop or her laptop as it does on mine. I can push it into the on-premises data center and expect the exact same result. I can push it into a hyperscale data center and expect the exact same result. Decoupling the application enables me to migrate across premises, across facilities. It realizes that notion that we started out with virtualization almost 10 years ago, where we want to be able to move our applications wherever we need them to be. So Docker decouples the application. They remove friction between development and operations. No longer do you have the, well, it worked on my laptop problem. No longer is, well, maybe development is still writing code and tossing it over the proverbial wall and asking operations to maintain it. But we're doing better about enabling that collaboration, about that communication, so that we know what to expect. And we're making it simpler. No longer do we have massive deployment scripts that say, deploy this operating system, configure these RPMs or these .debs, add these configuration files. Instead, the application developer owns that. They package it with their application, and it becomes significantly easier. So where does NetApp fit in all this? I mentioned before that one of my team's core tenets is enabling the developer, the application, at the native tools that they're using. And Docker is no different. Docker has the concept of a Docker volume object. Remember, containers are most often referred to as ephemeral. When I instantiate a container, it creates a copy-on-write snapshot, a copy-on-write layer on top of that file system. When the container is destroyed, so too is that copy-on-write layer. We lose any data associated with that. But we can take a volume and we can attach it to a specific point inside of our container, and that volume exists independently of the container. It persists. So since day one, the Docker user has been able to create those on local storage. Right? That's great if I want to run it on my laptop or one server in the data center. But what if I have a cluster? What if I have 100 servers that I need to run from? What if I need performance or reliability that comes from an enterprise storage system? So this is where the Docker volume plugin concept comes from. NetApp integrated exactly with that. We're not doing anything fancy here. We're taking advantage of the same 6 APIs that everybody who has a Docker volume plugin has access to: create, destroy, mount, unmount, path, and list. We take advantage of these APIs. We make it so that when that Docker user on their laptop, on their data center host, when they want to, say, consume ONTAP, when they want to consume SolidFire, when they want to consume E-Series, they simply say Docker volume create. It creates a volume for them, it maps it to the host, and when they execute the container, Docker run, it mounts that volume into the container and makes it available for them. They don't know anything about that underlying storage system. They don't care about it. All they want to do is consume storage. So that's exactly what we enabled. But we went a step further as well, working around some of the limitations that exist today, while simultaneously working with Docker in order to extend these paradigms. We've been able to do things like introduce, with NetApp's Docker volume plugin, the ability to do volume clones, where when I do a Docker volume create and list a source volume, in real time with the ONTAP and SolidFire platforms, it will clone that underlying volume. Developers love this. The concept of taking my live production data, cloning it out from underneath that production application and leveraging it in the dev and test process means that I can write better quality applications. Means that I don't have to rely on a backup that came from a week or a month or longer ago, or synthetic data, and hope that my database schema is accurate to production. The developers like the ability to use production data without affecting production. So containers are a thing. But it turns out that it's the same applications with the same persistence requirements. So over time, we expect these use cases to grow. We expect this utilization to grow and the capabilities to grow as we work with our peers across the industry as well as with Docker themselves. But Docker itself is, well, it's just a tool, right? Docker is great when I am a developer, when I'm banging away code, when I want to take that and encapsulate it, if my application is 1 or 2 or 4 containers, right? Microservices is the in vogue term. But what happens when my application is more than one service? What happens when it's a dozen services or 50 services spread across thousands of instances? Suddenly, the operations side of my brain kicks in and says, I really don't want to manage that. I don't want to have to go out and Docker run how many times, right? Or script out how to create these across my cluster. So we see a bevy of tools pop up to address these concerns. Container orchestrators. Container orchestrators add massive value. For those of us that have worked in the VMware ecosystem, think of this as the same thing as DRS. I simply say execute a virtual machine, I don't care which host in the cluster it is. Execute these containers, figure out where they need to sit, figure out how they need to connect, and oh yeah, please do things like storage as well. So container orchestrators create a platform for the applications to be deployed across dozens, hundreds, thousands of different physical or virtual resources. But not only that, they add numerous benefits to the application, right? Not the least of which is things like service discovery. If I have even the simplest multi-tier application, think WordPress. We all know and love WordPress. WordPress, at its simplest, is some sort of web server running PHP for WordPress itself, and a database for persistence. It's 2 services. So how can I reproducibly, right, across disparate infrastructures, how can I ensure that it's going to, I can simply say, connect to the database, right? We use service discovery to abstract that away. So that when I create a service named database or MySQL or whatever that happens to be, the web application simply says, connect me over here. And it addresses that. Things like load balancing. Having intrinsic load balancing that I don't have to think about, that I don't have to go to the network team and beg and wait, much like I do the storage team, if I have to go to the storage team, right? Make my life as a developer easier. Logging and monitoring. Just because we're running in containers doesn't mean that I don't need the logs. Doesn't mean that I don't want to make sure that my containers are running. So having the intrinsic capability of accumulating all of those logs and putting them into a common place is a powerful feature. One that we see many other startups popping up and other companies to address the collection and management of logs. So how do we know that orchestrators are popular? How do we know that this is taking off? Part of the OpenStack user survey survey from April of this year shows us, well, which orchestrators are being deployed. You notice that far and away, Kubernetes is the number 1. Interestingly, the third one down, OpenShift, is Red Hat's offering built on top of Kubernetes. So we have Kubernetes and Kubernetes Plus in the first and third slots. Roll Your Own is an interesting one all by itself. I've talked to customers who are doing this with Bash, with, heaven help them, Perl, with many, many different technologies, simply scheduling containers for their application across the infrastructure. This can be as simple as taking my old application that I used to deploy as an RPM and putting that RPM into a container, and then leveraging something like Puppet to, rather than deploy an RPM and the configuration files and everything else, it's just instantiating a container. So we see a whole bevy of these. We see them frequently, we see them often. Interestingly, some of these, like Mesos, we see as very, very large deployments. Mesos is leveraged for things like big data analytics, right? I want to have thousands of nodes executing my Hadoop or Spark or Kafka jobs. Right? And oh yeah, I want to run some containers on there, managed and scheduled by Marathon. So we see these across the board. But Kubernetes is the most frequent, by far the most frequent. And as a result of that, we've been doing a lot of work with Kubernetes. Kapil gave a fantastic presentation at OpenStack this week that looks at how stateful sets affect application scaling when we have a persistent data requirement. So Kapil is going to take the floor here and walk through not just the technology, but also demos of what this looks like, how it looks in action, and from an application administrator, application developer standpoint, the capabilities that they have accessible to them.